Recording. Thank you. Hello, welcome everyone. This is the Transformative Vertical Flight Working Group, number 4 in Public Services. And this is meeting number 81. Today is December 21st, 2023. I'd like to introduce today's speaker, which is me. So I'm going to call off most of the empty talk, and I think we have a potentially pretty interesting subject that we can cover today. The first one I'm going to, which is the agenda I added last minute, is rather than so-called FPV in the first-person view, which the drone people always use, I call it first-person flight experiences. I got a chance last Thursday to fly a lift aircraft HEXA single-seat eVTOL. I'm going to share a little bit of that here. And following that, I'd like to talk about the use of a eVTOL aircraft for military applications, last mile transport and logistic focus. And we're going to go through that and like to get more input and feedback and discussions. I have a list in the agenda, all the important folks, which most of them are working group members, have contributed to this SAE report. So appreciate that. I think that's a very, very impressive teamwork to put that report together, addressing some of the opportunities and challenges. So I'm going to talk about that. So with that, I'm going to first talk about some of the meeting that's coming. If I know how to advance my slide, there you go. All right. So we have some of the meetings coming up, which are kind of important. One of them is our next meeting is January 25th. And we're still working on the main speaker, but we're going to have a guest speaker from NASA to talk about the new SBIR expected to issue somewhere around January 9th. And that could be interesting. So we're going to have a discussion. And before that, actually, the same discussion or the information will also be available in January's working group 1. Well, we're changing that to commercial working group. Andrew also have our NASA friend Bruce to talk about that. So in case you can make one or the other meeting, you get a chance to learn about what the latest NASA SBIR program may cover. Okay. And a couple of interesting things on January 9th to 12th is consumer technology, consumer electronics show in Vegas. One of the elements or track in that show is the AAM, Advanced Air Mobility. So should have something interesting to learn from there. Also, almost the same time, unfortunately, overlapping the schedule, is the AIAA SciTech meeting, January 8th, 12th, from 2004 in Orlando, Florida. Actually, I'm scheduled to be there, so hopefully see some of you there. And in addition, there's a NASA Imagine Aviation. Some of you have attended that before, scheduled for February 27th to 29th. Now, one very important one on the right-hand upper corner is the 2024 Transformative Vertical Flight, the 11th Annual Electric VTOL Symposium and Aeromechanic Specialist Conference, February 6th to 8th, Santa Clara. I will be there. I know of several of our team members are going to be there as well. So I think we're going to try to connect have a little in-person gathering, brainstorming session there. Maybe Mike can help us coordinate that a little bit. All right. And
we'll have some extra rooms. I think that if you guys want to have a private or semi-private meeting or whatever, and Johnny, I haven't reached out to you yet, but I might need you to give a talk or chair a session or something. So just a heads up.
No problem. Be happy to. And thank you. And we definitely coordinate in the next couple of weeks. Well, other than Christmas and New Year time, we all need a little break there. But we'll definitely get that coordinated, and I will send out information. So anyone who can make it to get, sure would like to get together, have the chance to get together in person. And then there's another interesting one. It's a technical meeting on development, affordability, and qualification of complex system in Huntsville, Alabama. Now, following that, the February 26, 29 is also quite a bit relevant activities. It's HAI Heli Expo. That should be in Anaheim, yes, Convention Center. And one more in March, there's a SA Aerotech, which has always been a good meeting. So some of you might be interested in attending that one. So,
hey, Johnny, just sorry to interrupt, but VFS, we're having our 3rd annual hydrogen electric aero symposium there. That had been in Long Beach the previous 2 years, but anybody that's interested in hydrogen, aviation, particularly hydrogen electric fuel cells, we'll be having our meeting there as part of Aerotech in Charlotte.
Oh, that would be in Charlotte. Okay. Oh, that will give us extra reason to go there. All right.
So that'll be the second 2 days, the 13th and 14th at Aerotech. But yeah, we're gonna have a whole room and talk about hydrogen for 2 days.
You might just have convinced me to sign up for that conference again. All right. Hey, that's good. We have a lot of good meetings pretty much packed in the Q1. So I'm going to try to be as many as I can. Hopefully see some of you there. All right. Next. All right. Let me see if my control.
Who is sponsoring Aerotech?
Sponsoring Aerotech?
Yeah, what organization organizes that meeting?
SAE.
Okay.
Society Automotive Engineering.
Yeah, I know.
Yeah. Okay, good. All right. Now let's let me talk about flying this thing here, an eVTOL. Okay. Okay. Look at that picture. Guess who's in that galaxy?
A very
there's
brave
no passenger
man.
seat. There's only one seat. Okay.
A very
Is that
brave
Captain
man.
Do? Looks like Captain
You can
Do.
tell it's me, but it is me. And I'll show you how easy it is. That's perfect takeoff, right? This little crosswind, the vehicle automatically compensated. Actually, I wasn't controlling it. It's automatic takeoff. Okay. And this is me fooling around, okay? And it's piece of cake, it just does whatever I want to. And I'm coming back, watch my hands, okay? My hands off.
Wow.
You can see that.
Wow. Yeah.
That's a home function. You automatically go back to the pre-designated location and you push and land. You see both hands are off. It's auto land.
Johnny, where was this done? Where did you fly?
I'm sorry?
Where were you flying? What location?
This is in Austin, Texas.
So yeah, we need the background of like how you got this opportunity. I put down my $250 like 4 or 5 years ago to get a ride. So,
Just not enough.
You're gonna get to fly it pretty soon. I understand that the flight will be open to public early 2024. They went through one of the reasons why I get to fly in 2023. I had been Lyft's advisor for several years from early stage of the company establishment, and so I guess I get a little earned privilege to be one of the early not employee to fly it. I think there's only a handful of people who get that chance so far. But this time, they have a site set up over there in outskirts of Austin, Texas. That location has a. If you look at the picture, the image, there's a big space behind it. That's all available under that location. So what we have flown this time is a much more confined, geofenced area. So they let us go fly. Let me briefly describe the sequence. We got there, signing, and you got to sign the release and so on. But and then we get into the so-called training area. You basically watch a couple video training video. I don't know. I didn't look at my watch. I will guess maybe about 15 minutes total. And then you move into the simulator room, and they will fit you. While they're doing that, they take the opportunity to fit check you with the helmets and all that stuff. And but in the simulator, right now there's 4 simulators sitting there. When I was there, it took, I would say, probably 15-20 minutes to let everyone get a chance to fly through. They give you a kind of predefined maneuvering they try to get you to do, and then tell you that you can have a freedom to do whatever you want, and then how to get back safely in one piece. So it took, I think it's the whole group is 5 of us there, took about maybe 20 minutes through the simulator training. And then we go out there one by one, and they'll get you suited, geared, communication check, everything, strap you in, and you push. And once there's an instructor on the ground. So he has a remote controller in his hand. He can take over control anytime, I believe. And basically, but in reality, they never did any of those because the airplane truthfully fly itself. What happened was that it just there's a bottom. There's only one yoke. Okay, for anybody who's familiar with the flying helicopter, you got both feet. You got left hand on the collector. You got the right hand on the yoke. You're working full time. I have the chance to fly in a 2-seater helicopter, not as a pilot in command, but even with the expert pilot, you have to work at it. And this thing here, no pedal, no left-hand control, only one right-hand joystick, and all controls there. And that's it. So what you saw in the video, the total flight is longer than that. We cut off the middle part of the showing only just take off, a little bit hovering, maneuvering, and then coming back down. There's a button. You push a button, it take off automatically. So the first part, I didn't do it. The computer did the takeoff. And as I gain a little elevation, the crosswind picks up. The vehicle just automatically tilt to my right to compensate for that crosswind. The position of the airplane did not change. I mean, it just goes up vertically. So all the external disturbance and so on automatically get compensated. That's kind of what we talked about earlier. I'm a terrible pilot. I can probably take off in some of the airplanes. I may not be able to land safely in most of the airplanes. And I have to say that, and the last time I flew the little drone ended up in the trees. But flying this airplane, and with all the geofencing, the altitude limitation, the geometry fencing, auto takeoff, auto land, it kind of protect me from myself very well. That's my that's just my personal experience, saying that, hey, you saw me up there and spinning around. I got to move the joystick all the way to the left, all the way to the right, all the way forward, and combination of input. The airplane just do what your input is, and when you get closer to the geofence area, it just slow down. It doesn't give you a jerk; it just slow down, but you never get out of the geofence area. So for some of you may not be aware of, one of the Lyft's business model is they're setting up so that people can go through the $249 that Mike already signed up for. Experience flight. You go through kind of what I went through. Just take off for fun. That I have to say, yeah, that was a lot of fun. It's and no experience needed. One of five of us, one of the gentlemen has the helicopter experience, and he just compared that from his helicopter experience. Said this is so easy. Truthfully, from my experience, I would say pretty much anybody goes through that, half an hour, 45-minute total, no more than 1 hour at the ground school. Can easily fly this, and the way I felt about the airplane, it really pretty safe. Yeah, very safe and very benign. And we limit the control input in the beginner's level so that no matter what I do, it doesn't do overly crazy things. Yeah. So anyway, that's just my my 2 cents about. Oops, no, I want to show the. Okay, just to prove, I actually flew it. That's me in disguise. That show you a pretty good perspective what size airplane we're looking at. Yeah, it's really a pretty compact single seater. Yeah. So questions, suggestions, comments? And if anybody who's interested in flying without a license, this is a good way to do it.
And Johnny, how does that get transported? Does it break down in any manner, reassembled?
Yes. Actually, the upper arms can be folded, and I believe the side float can be easily removed. That's how they got it folded down into a transportable size to fit into, I believe it was the C-130 for the Air Force test program. So yes, I don't remember how long it takes. Maybe it takes a couple of hours to put it back together once you transport it to location.
Johnny,
is Kevin online? Kevin from Lyft say he might join us. So if Kevin's online, can probably answer that question better than I can. Well, I guess not. So, all right. But it didn't take very long. But they were able to, it was designed so that it can be made more compact for transport. Yes.
Johnny, did they, I remember them talking about a use case where they would be able to take tourists out and around the Statue of Liberty. Did they say anything about, and that they were making some progress and going through permitting, et cetera? Do you know if they're still on that track and when they expect their first, public availability type of deployment?
I understand the early 2024, the Austin site will be maybe the first public flying operations. Basically, what we're going through is have some of the so-called insiders to go through it, to provide feedback and input and check, make sure the operating procedure systems works. But the early 2024, this site should be the first one in operation. Has the space, everything set up for it, and so on, and the training facility set up for it. And then there's also there's a plan to take the airplane on the road. It will hit multiple cities, and many people in different cities have signed up for it. So it will be a tour operation. I do not know. Yes, we did talk about the Statue of Liberty tour flight experience, but I do not have the time when that can happen. Yeah, and we have also brainstormed about some other interesting locations. I think, to me, if you have a preset geofence location, it's a fun ride for experience flight and maybe the sightseeing at the same time. That would be fantastic.
Yeah,
and Statue of Liberty will definitely fit that criteria.
thanks.
Okay. All right. Anyway, yeah. Anybody interested? Just look up the lift. But I have to say that personal experience, I had a blast. It is fun. All right. So yeah. Next, we're going to talk about the use of eVTOL aircraft for military applications, focusing on the last mile transport and logistics. Okay. And this is based on the SAE Edge report. It's one of the research report. And you see our members that helped put this report together. I really appreciate, and Kurt, obviously, you're here. And also, Connor Diller, he has left the Air Force, and now he's in even more important position. So he's gonna be very helpful for sure in this adventure. This particular one for the military application is one of the 5 reports that we have published so far, and pretty much all with the help of our team members and some other experts in the field. So we're going to talk about this particular one, the military one, and the next one also recently published. Let's talk about the first responders and so on. So maybe in Q1 we'll get a chance to talk about that. And what we talk about really is the leverage the eVTOL advancement, the innovation and the system capability for military last mile mobility. As you can see that there's a lot of progress made, all kinds of different aircraft, different platforms, different technology, different capabilities, and different ones can fit into different environment, different use cases, different applications. And some of the use cases, there's 7, so I'll just go through them sort of quickly. So if you are interested in a particular subject, we can talk a little bit more. One of them is the absolutely distributed on-demand rapid deployment. Why distributed? Because some of the eVTOL can be fairly compact, and hopefully some of them will be cost-effective, affordable, which means and the simplistic in the routine use operating service maintenance. may allow us to have more of those units deployed in more places. So when there's a mission requirement, the platform may not have to be flown in from 500,000 miles away or 5,000 miles away. May have the capability, the mobility capability right on spot. Could be transport people, personnel for various missions, and could be cargo, supply, and whatever. And of course, the last mile resupply is one of the key missions that when I talk to the different armed forces people, that they point out that sometimes when we deploy for a mission, we have good planning, we have good capability, but mission changes, situation changes, and therefore sometimes we need resupply. Maybe the mission duration has been extended, or mission has changed, and therefore they need different kinds of equipment, different weapon system, different whatever, to be deployed on a as required basis. So some of the eVTOL may not quite have some of the heavy transport capability or heavy duty helicopter capability, but may have the ability to go in and in a more distributed fashion to be more available, more readily, short range, but get to the point exactly where you need it. So that's one of the use cases that seems to be that we got the feedback from the armed forces that those seem to be true, very, very well identified opportunities. Of course, some of them are designed to be able to transport in, kind of like the question we have earlier. Some of those devices can be folded and transport either on the roadway, on the trailer, or in the cargo container, which can be shipped around the world. That would be one of the critical capabilities to support this type of mission. And search and rescue and down pilot recovery. Many of the eVTOL we have today, the situation may change, but today many of the eVTOL are more limited by the range and endurance. So the more I look into it, it seems like it will be the eVTOL might be better suited for rescue part of the operation and have some of the drones do the search part. Can have a dozen drones that's launched and map out the search area, identify where the person need to be picked up and so on, and send out the eVTOL right to the point, point-to-point rescue operations. So that may be more a realistic pattern, operating pattern, rather than try to use the eVTOL for long endured search pattern, which will run a juice pretty soon, unless it's a hybrid or with alternative energy source. Now, additionally, there could be a way to recover the down pilot. I was told that typically we will have a Black Hawk. If we have a down pilot, we typically send out 2 airplanes, 2 Black Hawk with each aircraft may have 3 to 4 crew members on board. And you can hear them coming from miles away. And if you're into the contested area, you get shot at before you even know it, before you even approach the down pilot. So we're risking a lot of crew members and into a dangerous territory. And even if you successfully pick up the down pilot or pilot, on the way back, you're exposed to enemy fire again. So there's a lot of uncertainty and risk in the recovery of down pilot. And some of the possibility is that we send in autonomous eVTOL, compact unit, 1 or 2 seater or whatever, or even like a flying backpack shown here, that you fly the thing in at the, you deploy them from the safe zone, maybe just out of the enemy lines and so on, and fly them in, hopefully not too deep into the territory, and drop and land right next to near the pilot or the down pilot, strap it in, move themselves into a lay down if you're injured in the lay down type, or if you're not injured, this backpack will probably get you home. Not all the way to what the traditional rescue fleet is going to launch from, but probably at least get you to the friendly territory, so that you can be transported to the medical care centers and so on. So that's one of the use cases that being discussed and as a good possibility. Medevac, kind of what we talked about previously. Again, this is the sometimes the Medevac may be just in the safe zone, but you need to get people out, or it could be in the enemy zone that you need to get people out. So in this case, in showing it's a lift aircraft with a stretcher underneath. There can be a larger unit that we equip with actually 4 or 5 seat eVTOL. You can have a stretcher with the medic in the airplane. So it depends on the mission, what the requirement is. If you just need to get somebody to the hospital quickly, compact unit may be a smaller target, lower noise. You can fly under the radar, truthfully, under the radar. Low altitude along the tree line, get to the site. There could be a mission that 1 or 2 seater that the medic can fly into the where the injured person are. Get out of the airplane, stabilize the patient, whatever, and if necessary, and if they need it, load that person into and push a button. The medic can stay on the ground. We send another empty airplane out to get him back. So there's many ways of the eVTOL can be used for Medevac. May not be the same way we use Medevac helicopter today to expand and enhance the capability compared to what we have. I'm not talking about replacing the current capability, but to complement the current capability. One more is about distributed ship-to-shore or ship-to-ship logistics. We have a lot of capabilities currently in the U.S. military, and many other countries also have some of the capabilities. But eVTOL could be a interesting addition to that capability. For one thing, some of the eVTOL are smaller than other cargo transportable or mission-capable platform like a V-22. V-22 take quite a bit, or even Black Hawk take quite a bit deck area to operate, and the ship tonnage also comes into the equation. But some of the eVTOL could fit into the smaller, shorter range logistic missions, more sorties right to where people need it, rather than large, heavy payload and then redistribute them. So there can be a complementary operation and possibly be fitted onto ships, smaller ships, that not suitable for heavy aircraft like the V-22 or Black Hawk or Seahawk helicopters. And the the eVTOL could fit if you want to do a pyramid of transport, the smaller, lighter weight packaging, delivery, logistics to be more effective. And of course, disaster and humanitarian response, military quite often got caught upon when major disaster occurs. Sometimes even beforehand, a lot of times respond to it. It can be helped to pre-event evacuation, and especially some people got last minute before hurricane hit or whatever, or wildfire. People, the traffic got jammed. We can go in and pick up, land in the schoolyard, and get some of the last minute evacuee out of the area. At the same time, eVTOL will be very effective in getting the medical personnel or emergency ration into the disaster area, especially when the roadways are blocked and the bridges down and so on. That the military quite often respond to that. For example, the Puerto Rico major hurricane disaster, our military are key into getting the supply into the area, but eVTOL can make that last mile deliveries right to where people need it. And the last item I want to talk about is the movement of emergency electric power during contingency operations. Our military are getting, just like the rest of us, are getting more and more electrified. Sometimes it's the electric equipment. Sometimes it's a lot of things that depend on the electricity, and it's including when we deploy eVTOL. Once we deploy the eVTOL, if it's a hybrid power use jet fuel, okay, that's fine. But if it is battery powered, you need to charge it up. Then you need electricity. So one of the possibilities is to use eVTOL as a point-to-point delivery of emergency power. Sometimes it's because of disaster, sometimes it's because accident, cyber attack, military strikes, or whatever reason that you out of electricity. eVTOL can play a role in there. I took an example, did a little math and saying, well, if it's an internal combustion engine driven aviation grade, which is more weight efficient than what you can buy at the Home Depot. But one of those engines can, the one example I pick, can generate 185 kilowatt for output. That's pretty decent juice providing, but the weight's about 650 pounds. So if it's 1,000-pound payload eVTOL, we can still put in about 50 gallons of jet fuel in there for this engine. That can last about 4.5 to 5 hours. And of course, then you need the next wave of a fuel supply to keep up with the usage. So it could be. Yeah, go ahead.
Johnny's presenting on the working group, so it's cool.
Yeah. So anyway,
sorry about that, Johnny.
No problem. Yeah, thank you. And it's interesting that seems like at first I said, well, eVTOL ain't going to be able to do much good in this aspect. But when I look into it, do a little math, I say, oh, you know what? Yeah, it can make a difference, especially the first responder type emergency power usage needs. And of course, you need much larger, much more power capability via ground or via heavy transport or whatever following, but this could be the first wave of problem solving. Now, of course, everything we talk about, and there's a lot more, are interesting and with a great promising potential, but there's a lot of challenges. I'm not going to go into too much detail, but highlight some of these challenges. One is opportunities, okay? Government industry collaboration, which some of them are ongoing right now. Like the Air Force are working closely with the eVTOL industry, and other services are engaging as well. And of course, the vehicle technology and capabilities, and some of the military needs and the use cases need specific technology that may be a derivative of the commercial capabilities that will be need to be adapted properly. And of course, mission-specific platform, the eVTOL platform development, a lot of times, just like helicopters industry, that a lot of times it can be a commercial platform, but mission tailored for military use. And of course, the autonomous swarm capability and artificial intelligence, those are going to be debatable, certifiable, may or may not be by the FAA or ELSA upfront, but in some use cases, especially with low risk to the ground, sparse populated area and so on, some of the use cases maybe just like Air Force can approve certain and certify for government use. So that open up some additional opportunities in that direction. Of course, simplified vehicle operations, which is going to be critical. Training and maintenance, not just flying it, but also keep up with it. Fortunately, from my flying experience, I'll say, I think we can train many of our service members to fly this type of vehicle safely. I think it's that's a joke that if I can fly, anybody can fly. Okay. And fortunately, hopefully, the maintenance also on the simplified compared to current aerial vehicles. The service maintenance and the reliability actually may be pretty good. And of course, other challenges could be system reliability, redundancy, and survivability. Now, in military, in civilian use, we don't quite count as being shot at. But if we are to put it in the military services, survivability has to be taken into account. And of course, supply chain management and security, that has to be looked at, monitored and developed. Flight management and airspace control network, NASA, FAA is working on that. Perhaps some version of that can be adopted fit into the military airspace mission management and controls and so on. So I think it's a matter of learning the best practice and with a good system, reliable, adaptable, and flexible system for those missions. And we kind of talk about that a little bit, the transportability, dynamic deployment, logistics support, which means if eVTOL typically has a shorter range or medium range capabilities, then we may have to have a way to move them quickly to further distance, by other means, either by air transport or by ground transport, to closer to the mission site in order to deploy them for the operation. And of course, unconventional use cases, operational evaluation. eVTOL can be doing similar thing but different, or doing very different mission than what we have today. So we need to kind of open our mind to say, okay, what's the best way to leverage the capabilities to complement what we have today? That takes some out-of-box thinking and probably get the operator. You identify some of the Army team, certain team, or the Coast Guard, say, hey, we're going to use it. Get some of the people to try it and operate it, test it, to find best way to use it. Until you put it to work, we probably don't know all the answers. Just a little bit point out that for the military operations, the transportability and deployability, you can see the picture on the left is, the Robinson is pretty good because, when you get the rotor in the right direction, you can tow it on the highway, and we need some of the capability for eVTOL as well. And the middle picture, lower picture, is showing that the command unit that they're developing right now is designed to be shipped within the cargo container, which is very, very useful for global deployment. Of course, the whole airspace protection system and management system will be need to be developed and implemented. And of course, the eVTOL, the charging and fueling, we'll talk about that. Now, the lower picture is showing the National Guard base. Okay, that should be pretty easy, with all the this power availability, the space available, and so on. That maintain and charging eVTOL, if you operate from there or deploy from there, that should not be a problem. But once you're out there, that's a challenge. We have SA committee working on the charging standards. Are we going to try to be compatible with the automotive, or the megawatt truck charging standard, so that when we deploy, because not always military deployment is for battle zone. That's a different story. You need a truck, with moving, or the flying generator, as we talked about earlier. But if it can be, I'm trying to encourage people to do that, is if it can be, let's say, truck megawatt charging standard compatible, or the NACS, many of the automotive companies are now switching over to North American charging standards. The Tesla now become public standard. If we can reduce the VHS and beta scenario, that the more places we can go, especially on disaster relief, humanitarian aid, whatever, we have more ability to utilize the existing or will be in place automotive facility. That would be nice. But that's yet to be developed. Of course, if we're using hydrogen, what is the logistic? What is the way to get them in place and where it needed to be, and so on? Especially for military operation, they try to simplify the logistics, so that has to be worked out. And we'll talk about the where do you operate from? If it's a peacetime or planned deployment, stay there, staging them for a while, then GA Airport would be pretty useful. They are pretty well set up, very ideal for eVTOL operations. Of course, lately I've been promoting the use of sports fields, like in North America, we have a whole bunch of football field. High school football field. There's over 15,000 high school football team, and many of them have their own field. And it's wide enough and big enough. You just try to make sure that you don't hit the light post. Even the baseball field, the baseball diamond field, that can probably work. Land a couple of eVTOL there too. So, and the facility probably have enough. The school may have enough electricity for slow charging, not fast charging heavy duty eVTOL. But if you put a battery bank in the truck over there, then you have a temporary setup you can operate with the navigation, terminal control, and so on. So those are possibilities. Of course, if you're in the battle situation, you may have to go into any street corners, if it's urban warfare, open field, on the beach. But the beauty is eVTOL may be able to get into and operate from more places than before. Of course, global deployment will still pose significant challenges. But as I say, eVTOL can be more flexible than current assets, so that's a benefit. So basically, I think we pretty much covered most of the topic here. That basically, my point, I think what we did through this work of this report is that we think there's that the eVTOL technology is a good opportunity to really enable new capabilities for dynamic mobility for the military. So a lot of things to do, still challenges. but definitely promising. So, now with that, sorry, take a little longer, but let's. Any comments, questions, suggestions, things that we should be looking at?
Very good. Good talk, Johnny. I would reinforce your points. I also believe that the requirements for autonomy are much more gentle than those for a ground vehicle. That mostly air vehicles can move above the ground plane and can make decisions only as they come closer to obstructions for landing or takeoff, but otherwise can carve a path, even in a contested military environment, that is relatively free of obstructions, and therefore a much simpler autonomy task than what we saw with the DARPA Grand Challenge and the ground vehicles, and the need to drive through Boston, which is a nightmare. So that's number one. Number two is I think the flight control systems are going to provide the ability for the average human to drive it about like you drive a car. Amount of training required is a few hours. There'll be a simple test. And that also the system will probably have an auto land capability. So even if the operator, the nascent pilot has a problem, that an auto land with an eVTOL is a rather straightforward task. And the systems that allow you to see obstructions for landing and takeoff would also be able to carve a path the size of the vehicle down to a safe landing in many, many places. So I think that you'll find it be easier to do that. And I would say, too, that most of the questions you got are going to be developed as we build a civilian system, and it'll be nicely grafted over toward military usage, in a selected basis.
Yeah. Well, I 100% agree with you. I mean, I rented a Tesla Model 3 when I was in Austin and tried to. I don't mean to say Tesla is not good, but I have to say it was more challenging for me to figure out how to drive a Tesla than I was able to fly the HEXA. And the auto drive, the autopilot, it works to some degree, but not bad. But I agree with you. I think from autonomous perspective, the aerial capability with the drone technology that's being pretty well developed, implement that to the eVTOL, it really enables pretty good. I mean, you saw the video. I put my engineering hats on when I was coming back for landing. We have a choice: either manually fly the airplane back to the landing location, and then auto land. I choose to test the system. I say, how good is the home button? So when I fly it, I was slightly away from the actual landing pad location. I push the home button for 1 second. It basically just takes me back to, right back, turn the airplane straight to the landing site, and then just hover there. And then I push the land button, it lands. So, if we were in a, say, a military personnel, even young folks, 20, 25 years old, in service, that for them to come to a location, say this is pre-programmed landing location, and I guess I got some obstacle on the ground, but my airplane is hovering like 10 feet above the ground. I'm not hitting it, so I can manually move the aircraft to the right, by 20 feet. And then push the land bottom and land safely. So there's a lot of capability. I think that simplified vehicle operation it's gonna be a lot simpler than many people think it is. Yeah. Thank you for the input. Yeah, I agree. I think it's more doable.
And let me also add
a little bit more, more capable, more near-term feasible than even ground vehicles. Yeah.
And a quick study of the complexity of the electric air vehicle shows, without a transmission, without a detailed flight control system, that the maintenance should be in the order of half to a third of the maintenance of a typical helicopter, and therefore shifts the paradigms greatly in terms of the cost to operate and the training of the crews to do the maintenance.
Yeah, I agree. The electric motor highly reliable nowadays. The control, on the HEXA, the flight computer it's a triple computer. So basically it's fail safe. The whole vehicle can be pretty much any eVTOL can be designed to be fail safe if we wanted to. So that and the maintenance back comparison. I spent many years working in the aircraft company. I spent some years working in the engine company. I have to say that's a lot of work. A conventional airplane, but the eVTOL by comparison, yes, simpler. Yeah.
Well, when I helped to work on the Comanche back when, and all the motors on the Comanche had the ability to track their amperage during startup. So you get a feeling for the bearing health and the winding health of the motors, because the amperage rise as the fan runs up in speed gives you a very direct index of how easily the system rotates, and that could be applied so that prognostics and diagnostics for the motor driven systems on eVTOL should be rather straightforward and give you direct numerical assurance of reliability.
Yep, you're absolutely right. I mean, it lends itself into the preventive maintenance very well.
Yeah.
Okay, well, folks, I guess it's already past our time, so I think I better call it end to this session. But thank you so much for attending, and please send me notes, send me email, call me. Let's talk more. I will more than welcome everybody's input and feedback, and let's also think about what else we should look at, what else we should think about as a working group together.
Hello, Johnny.
Yes.
Long time no talk. I had an idea when I got the meeting notice.
Okay.
Could the eVTOLs use the technology from the DARPA Power Project? They might have to scale it up and increase the efficiency, but they could beam the power to the eVTOLs using lasers.
Oh, okay.
So you could have like an aircraft that would be flying around and beaming power to the eVTOL to get it to wherever it needed to go.
I see. That would be interesting to see at what stage the development are maturing that can bring enough power to either extend the flight range or supply adequate power. eVTOL does take a lot of juice.
Yes, sir.
Worse than the ground vehicle, because the ground vehicle has the tires on the ground, and eVTOL has to sustain its own weight by propellers or rotors or whatever. But yeah, okay, sounds interesting. We definitely should follow up on that one to see where they are, where they stand. Sounds good. All right. Again, thanks everyone.
Thank you, Johnny.
See you guys next time.
Interesting meeting. Thank you.
Thank you.
Thanks, Johnny.
All right.
Thank you, Johnny.